This is JSteele's Precalculus, Section 9.8, and we're going to be learning about partial fractions. If you can recall from Algebra 2, if we were given an expression that looked like 2 over x plus 3 plus 1 over 3x minus 4, and we were asked to simplify, our first step would be to find a common denominator. Our common denominator in this case would just be the x plus 3 times 3x minus 4. And for the first term, the 2 over x plus 3, we would have to multiply that by 3x minus 4, and we'd have to multiply the second term by x plus 3. So we would end up with 6x minus 8 over our common denominator plus x plus 3 divided by our common denominator. So just combining like terms, we would be left with 7x minus 5 divided by x plus 3 times 3x minus 4. We will be using this knowledge from Algebra 2 to rewrite these expressions in partial fraction form. So in partial fractions. We'll be learning how to do this today. So taking a look at the first case is when the denominator has a linear factor. Example 1, it says decompose into partial fractions the expression 8x minus 3 divided by 2x squared minus x. Our first step is to write the denominator in factored form. So we can take 2x squared minus x and take an x out. We can factor out an x and we're left with x times 2x minus 1. Once we have this step, our next step is to decompose into partial fractions. So we will still have the 8x minus 3 over x times 2x minus 1. But that will be set equal to a, we're just having a variable a, divided by one of our factors, x, plus another variable b, divided by another factor, 2x minus 1. Our third step is to multiply by the least common denominator, or the lowest common denominator. Our LCD in this case is just our factored out denominator, x times 2x minus 1. So if we multiply each term by x times 2x minus 1, we'll have 8x minus 3 times x times 2x minus 1 divided by x times 2x minus 1 equaling a times x times 2x minus 1 divided by x plus b times x times 2x minus 1 divided by 2x minus 1. Now looking at what cancels out, in the first term, everything but the 8x minus 3 cancels. In the second term, everything, or the x's cancel. In the third term, the 2x minus 1's cancel. So now we just need to distribute and add like terms. So we're going to still have the 8x minus 3 equals, we're going to have to distribute the a to both the 2x and the negative 1. So we have 2ax minus a plus, then we're going to be taking just b times x, so just plus bx. So now we want to combine like terms. Notice that we have 2ax and we have a bx on the right-hand side. We will not be worried about moving anything to the left-hand side right now, so I'm going to leave the left-hand side alone. So 8x minus 3 equals, however, I'm going to take the bx and place it next to the 2ax, and we can do this because addition is commutative. So we have 2ax plus bx, and we cannot forget about that minus a. So now if you just get all of our x terms together, again, I'm going to leave the left-hand side alone, so 8x minus 3 equals, then I'm going to factor out an x. So I'll have 2a plus b times x minus a. So now once I have this down, I'm able to write a system and solve. If you can notice, we have our 8x and we have our 2a plus b times x. And we also have -3 and -a. When writing out our systems, we're going to be taking the x terms and setting them equal. So we have 8x. Well, that must be equal to 2a plus b times x. And we also know that this -3 must be equal to the -a. So once we have our system, we are able to go from there and solve. So our first step, since we have an x on both sides, dividing by x will just make that x cancel out. So now we just have 8 equals 2a plus b. And from here we're kind of stuck because we have two unknowns in one equation. So looking at the -3, or -a equals -3, just dividing by -1 tells us that a equals +3. Using that bit of information, we can substitute that into the 8 equals 2a plus b. And we're left with 8 equals 2 times 3 plus b. So 8 equals 6 plus b. Subtracting 6, we have b equals 2. So our last step is just to express the answer in terms of fractions. So once we have our a equals and our b equals a number, we can rewrite the original 8x minus 3 over 2x squared minus x. And we know that that equals, since our a value is 3, and we, in the original, when we first factored out in step 2, decompose into partial fractions, we had a over x. So we're going to have 3 over x plus our b, which is 2 over 2x minus 1. So this is the final answer if asked to express the answer, or express the expression in terms of partial fractions. For example 2, it says decompose into partial fractions. So again, our first step is to factor out our denominator. So we will have x plus 2 times x minus 2. So rewriting this in terms of partial fractions, we have 4 over x plus 2 times x minus 2. Set that equal to, since there's two factors, we know we're going to end up with two variables. So a over x plus 2 plus b over x minus 2. After we multiply by the LCD, we'll be left with 4 equals a times x minus 2 plus b times x plus 2. Now just distributing out our variables, we have 4 equals ax minus 2a plus bx plus 2b. So then just combining like terms, we have 4 equals a plus b all times x plus -2a plus 2b. So in this case, there's no x term on the left-hand side. So notice that there's no x term. That means that we're going to set all of the x terms on the right-hand side equal to 0. So we're going to say 0 equals a plus b. So now that means that if we were to solve for a equals -b. And we also know that since 4 is our constant term, we'll have 4 equals -2a plus 2b. So we'll be taking the fact that a equals -b, and we'll be plugging that into the constant equation. So we have 4 equals -2 times -b plus 2b. So 4 equals 2b plus 2b. So 4 equals 4b. and thus b equals 1. Since b equals 1, we know that plugging this into the equation that we had set up for a, we know that a equals -1. Now, writing our equation out in our partial fractions form, we'll have 4 over x squared minus 4. That's our original equation that we were given. And that equals -1 over x plus 2 plus 1 over x minus 2.